Section 517.18. B2 of the National Electrical Code requires hospital-grade type ground fault circuit interrupter, or GFCI, devices at patient bed locations and in other general care areas of the nursing home where portable electrical or electronic equipment can be used by patients. Bathrooms, including resident bathrooms, are not explicitly mentioned in this requirement. However, it is reasonable to interpret that hospital-grade GFCI devices should be used in resident bathrooms where portable electrical or electronic equipment is likely to be used, such as electric toothbrushes or shavers. Section 210.8 of the National Electrical Code defines general care areas as areas such as corridors, lobbies, dining areas, geriatric daycare rooms, or similar areas that are intended for use by patients, clients, or residents but are not within a critical care area. Resident bathrooms can be considered general care areas, as they are intended for use by resident. Therefore, it is best practice to install hospital-grade GFCI devices in resident bathrooms of nursing homes to ensure patient safety and compliance with applicable codes. Considering the electrical safety within healthcare facilities, particularly in nursing homes, it's crucial to address the specific requirements and best practices for ground fault circuit interrupters. The primary objective is to protect residents from electrical shock hazards, especially in areas where they are most vulnerable. Firstly, let's delve into the purpose of ground fault circuit interrupters. These devices are designed to detect even the smallest leakage of electrical current to ground. When a ground fault is detected, the GFCI trips, immediately cutting off the power to the circuit. This rapid response prevents dangerous electrical shocks, which can be particularly hazardous for the elderly and those with medical conditions. Secondly, understanding the scope of Section 517.18. B2 of the National Electrical Code is essential. This section mandates the use of hospital-grade type GFCI devices at patient bed locations and in other general care areas of nursing homes. The key phrase here is general care areas, which are defined more broadly in Section 210.8, to include corridors, lobbies, dining areas, geriatric daycare rooms, and similar spaces intended for use by patients, clients, or residents. Now, the question arises regarding resident bathrooms. While not explicitly mentioned in Section 517.18. B2, the intent of the code is to ensure electrical safety in areas where patients or residents may use portable electrical equipment. Consider the potential for residents to use electric toothbrushes, shavers, hair dryers, or other small appliances in their bathrooms. The risk of electrical shock in a bathroom environment due to the presence of water is significantly higher. Thirdly, the argument for including resident bathrooms as general care areas is strong. These bathrooms are clearly intended for use by residents and are not classified as critical care areas. The rationale for using hospital-grade GFCI devices in these bathrooms is based on the potential for portable electrical equipment use and the inherent risk of electrical shock in wet environments. Hospital-grade devices are specifically designed to meet higher standards of durability and reliability, making them suitable for the demanding environment of a healthcare facility. Furthermore, the installation of hospital-grade GFCI devices in resident bathrooms aligns with the broader principles of electrical safety in healthcare settings. These principles prioritize patient safety and aim to minimize the risk of electrical hazards. It is important to note that while the code may not explicitly mandate GFCI protection in resident bathrooms, it is a prudent and proactive measure to ensure resident safety. Best practices in electrical safety often exceed minimum code requirements, especially when dealing with vulnerable populations in healthcare facilities. Moreover, local regulations and interpretations of the National Electrical Code may vary. It is crucial to consult with local electrical inspectors and authorities to determine the specific requirements in your jurisdiction. They can provide guidance on the application of the code and ensure compliance with all applicable regulations. Additionally, consider conducting a thorough risk assessment of the resident bathrooms. This assessment should evaluate the potential hazards associated with electrical equipment use and the vulnerability of residents to electrical shock. The results of the risk assessment can inform the decision-making process regarding GFCI protection. For example, if the risk assessment identifies a high potential for electrical shock, the installation of hospital-grade GFCI devices may be warranted, even if not explicitly required by the code. In summary, while the National Electrical Code does not explicitly mandate the use of hospital-grade GFCI devices in resident bathrooms of nursing homes, it is a best practice to do so. Resident bathrooms can be considered general care areas, and the potential for portable electrical equipment use and the inherent risk of electrical shock in wet environments justify the use of these devices. By installing hospital-grade GFCI devices, you can significantly enhance the electrical safety of resident bathrooms and protect vulnerable residents from electrical hazards. Always consult with local electrical inspectors and authorities to ensure compliance with all applicable regulations and to determine the specific requirements in your jurisdiction. Now to further discuss the nuances of GFCI installations and their relevance in healthcare settings, we should consider several key aspects. One involves the types of GFCI devices available and the importance of selecting the appropriate type for the specific application. Firstly, there are two main types of GFCI devices: receptacle type and circuit breaker type. Receptacle type GFCIs are installed directly at the outlet and protect only the specific outlet and any outlets wide downstream on the same circuit. Circuit breaker type GFCIs, on the other hand, are installed in the electrical panel and protect the entire circuit. Secondly, for healthcare applications, hospital-grade GFCI receptacles are generally preferred. These receptacles are designed to meet more stringent performance and durability standards compared to standard GFCI receptacles. They typically feature heavier-duty contacts and a more robust construction to withstand the demands of a healthcare environment. Furthermore, the installation of GFCI devices should be performed by qualified and licensed electricians. Proper installation is critical to ensure that the devices function correctly and provide the intended level of protection. The electrician should verify that the GFCI device is properly grounded and that the wiring is correctly connected. Now let's examine the testing and maintenance of GFCI devices. Regular testing is essential to ensure that GFCI devices are functioning properly. GFCI receptacles typically have a test button that can be used to simulate a ground fault. When the test button is pressed, the GFCI should trip, cutting off power to the circuit. It is recommended to test GFCI devices at least once a month. Also, it is crucial to implement a comprehensive electrical safety program within the nursing home. This program should include regular inspections of electrical equipment, training for staff on electrical safety procedures, and protocols for reporting and addressing electrical hazards. In addition, it is crucial to consider the specific needs and vulnerabilities of the residents when implementing electrical safety measures. Residents with mobility impairments, cognitive impairments, or other medical conditions may be at increased risk of electrical shock. The electrical safety program should address these specific needs and provide appropriate safeguards. For instance, residents with mobility impairments may have difficulty reaching electrical outlets, so it may be necessary to relocate outlets or provide assistive devices. Another point worth mentioning is the coordination with other safety systems. Electrical safety should be coordinated with other safety systems in the nursing home, such as fire alarm systems and emergency power systems. This coordination helps to ensure a comprehensive and integrated approach to safety. For example, the fire alarm system should be designed to automatically shut off power to certain circuits in the event of a fire. Also, the emergency power system should provide backup power to essential electrical equipment, such as life support systems, during a power outage. Furthermore, it is important to document all electrical safety measures that are implemented in the nursing home. This documentation should include records of inspections, testing, maintenance, and training. The documentation serves as a valuable resource for demonstrating compliance with regulations and for identifying areas for improvement. To recap, the installation of hospital-grade GFCI devices in resident bathrooms of nursing homes is a best practice to enhance electrical safety and protect vulnerable residents from electrical hazard. by adhering to code requirements, consulting with local authorities, implementing a comprehensive electrical safety program, and coordinating with other safety systems. Nursing homes can create a safer environment for their residents. Now let's discuss the practical considerations of implementing these measures in a real-world setting. When planning the installation of hospital-grade GFCI devices, several factors should be taken into account. One involves the number of devices required. This will depend on the layout of the resident bathrooms and the number of electrical outlets in each bathroom. The goal is to provide GFCI protection for all outlets that are likely to be used by residents. Secondly, the location of the GFCI devices should be carefully considered. The devices should be readily accessible to residents and staff, but they should also be protected from damage or tampering. It may be necessary to install the devices in recessed boxes or behind protective covers. Also, the cost of the GFCI devices and their installation should be factored into the budget. Hospital-grade GFCI receptacles are typically more expensive than standard GFCI receptacles, and the installation costs can vary depending on the complexity of the wiring. Therefore, it is advisable to obtain multiple bids from qualified electrical contractors to ensure that you are getting the best price. Now to dive into the specific requirements outlined in the National Electrical Code, or NEC, let's consider Section 517.13. This section addresses the grounding and bonding requirements for electrical systems in healthcare facilities. Proper grounding and bonding are essential to minimize the risk of electrical shock and to ensure the reliable operation of electrical equipment. The NEC requires that all electrical equipment in patient care areas be grounded to a common grounding point. This helps to prevent voltage differences between different pieces of equipment, which can create a shock hazard. The grounding system should be regularly inspected and tested to ensure that it is functioning properly. Another relevant section of the NEC is Section 517.16, which addresses the requirements for isolated power systems. Isolated power systems are used in critical care areas such as operating rooms to provide an extra layer of protection against electrical shock. These systems isolate the electrical supply from ground, which reduces the risk of current leakage. It is important to note that isolated power systems are not typically required in resident bathrooms of nursing homes. Also, Section 517.19 provides guidance on the use of flexible cords and cord-connected equipment in patient care areas. Flexible cords should be of the heavy-duty type and should be inspected regularly for damage. Cord-connected equipment should be grounded or double insulated to provide protection against electrical shock. All electrical equipment used in patient care areas should be listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or UL. This listing indicates that the equipment has been tested and found to be safe for its intended use. Always refer to the latest edition of the National Electrical Code and consult with local electrical inspectors to ensure compliance with all applicable requirements. Remember that electrical codes and regulations are constantly evolving, so it is essential to stay up to date on the latest changes. Now, to further emphasize the importance of electrical safety in nursing homes, consider the potential consequences of electrical hazards. Electrical shocks can cause a range of injuries, from minor burns to cardiac arrest. In severe cases, electrical shock can be fatal. Elderly residents and those with medical conditions are particularly vulnerable to the effects of electrical shock. In addition to electrical shock hazards, there are also fire hazards associated with electrical systems. Overloaded circuits, faulty wiring, and damaged electrical equipment can all cause fires. Fires can spread rapidly in nursing homes and can pose a serious threat to the safety of residents and staff. By implementing comprehensive electrical safety measures, nursing homes can significantly reduce the risk of electrical hazards and protect the well-being of their residents. Now we will discuss the role of education and training in promoting electrical safety. Electrical safety training should be provided to all staff members who work in the nursing home, including nurses, certified nursing assistants, maintenance personnel, and administrative staff. The training should cover the basics of electrical safety, including the identification of electrical hazards, the proper use of electrical equipment, and the procedures for reporting electrical problems. Staff members should also be trained in the use of GFCI devices and the importance of testing them regularly. They should also be instructed on what to do in the event of an electrical shock or fire. Furthermore, residents and their families should also be educated about electrical safety. They should be informed about the potential hazards of using electrical equipment in the bathroom and other areas of the nursing home. They should also be encouraged to report any electrical problems or concerns to the staff. Educational materials, such as brochures and posters, can be used to reinforce electrical safety messages. The educational material should be written in plain language and should be easy to understand. Electrical safety is a shared responsibility, and everyone in the nursing home community should be involved in promoting a safe electrical environment. It's also important to create a culture of safety within the nursing home. This means encouraging staff members to speak up if they see something that is not safe and empowering them to take corrective action. Management should demonstrate a commitment to electrical safety by providing the resources and support needed to implement and maintain a comprehensive electrical safety program. This commitment should be communicated to all staff members and residents. Regular safety meetings can be held to discuss electrical safety issues and to reinforce safety messages. These meetings provide an opportunity for staff members to share their experiences and to learn from each other. By fostering the culture of safety, nursing homes can create a more secure and protected environment for their residents. Let's address some common misconceptions about electrical safety. One common misconception is that GFCI devices are only needed in bathrooms and kitchens. While GFCI protection is particularly important in these areas due to the presence of water, it is also beneficial in other areas of the nursing home, such as resident rooms and hallways. Another misconception is that GFCI devices will prevent all electrical shocks. While GFCI devices provide a high level of protection against electrical shock, they cannot prevent all shocks. For example, GFCI devices will not protect against shocks that occur between two energized conductors. A third misconception is that electrical cords can be used to power multiple devices. Overloading electrical circuits can create a fire hazard. Only use electrical cords and extension cords for their intended purpose. By dispelling these misconceptions and promoting accurate information about electrical safety, nursing homes can help to prevent electrical hazards. In summary, electrical safety is a critical concern in nursing homes. By installing hospital-grade GFCI devices in resident bathrooms, implementing a comprehensive electrical safety program, providing education and training, fostering a culture of safety, and dispelling common misconceptions, nursing homes can create a safer environment for their residents. Electrical safety is an ongoing process that requires continuous attention and effort. By prioritizing electrical safety, nursing homes can protect their residents from electrical hazards and promote their well-being.